open up the chat. Okay, where did the chat go? Right here. All right. And then we talked about the first question, rabbit problem. Do you guys remember that? You start out with the 50 rabbits. So the A is going to be 50, and the rate of increase is 7%. Now, what do? You need to do two things, right? You need to treat 7% and do two things. One is you divide that percentage, it's 7%. So you do 7 divide by 100, and you will get 0.07. That's a 7% in decimal form. But you need to also add 1 to it. And so you will have, let's see. You need to add 1 in front of it, because you don't want to just have a 7% of the rabbits, right? But you want to keep all the other 50 rabbits from last week and 7% more. That if you want to bring all 100% of the rabbits back and a 7% more, you need to have a 1, because 1 represents 100%. Yeah, does that make sense? So the rate will be not just 0.07, but it will be 1.07. Okay, and so that's what we talked about yesterday, and we've had the assignment for that. If you missed the class, please watch the video. It's been already uploaded. Now we will be talking about today exponential decay problem. When you see the word decay means to like a rot, right? In more of a common terminology. But in mathematical setting, exponential decay represents the pattern that exponential patterns that goes down, usually in number and the value. Okay. So what kind of things go down in value? Well, here's the example. Let's use the car. Most of the car, 99% of the car that we all purchase will go down in value. Okay. Or what else can you think of things that go down in value? Pretty much everything that you consumer products, everything that you buy, right? The TV. Let's say you buy a TV right now. The next year it's going to be less worth than previous year. Computer, just about anything, right? Everything that you buy, it goes down in value. Right? So let's use this example here. So you buy a car. Let's say you buy a used car, and you paid for $5,000, $5,400, and you bought that. That's a pretty decent car, right? Yeah. Is it? Any of you are big car? Like to work on cars and like to. Anybody like to work on cars and things like that? Anyway, so you buy the car, but the car is said to be decreasing in value 12% a year. Okay. So first, let's just do figure out the value of the car in by table. So year 1, that's when you purchase the car. The value is $5,400. Now, what would the car be worth next year? I'm not going to tell you anything right now, but can you think about the price, the value of the car for next year? It's not going to be worth 5,400. It's going to be less. But exactly how much? Let's take a minute to figure out. That's right. Very good. Francisco has a, can you all guys see the chat? You're going to lose 12% of the value. All right. And have you done something like this before? Exponential decay problem? Maybe this is just a review problem. Yeah, okay, you have. So, okay. Well, that will make my job easier. I hope this is not too boring for you. But let's go through this. Okay. Maybe some of you might have forgotten what to do. Okay. Now, let's first of all, actually, let's figure out 12% of 5,400. Okay. How do you figure out the percentage of something? You guys remember that? How do you figure out 12% of 5,400? Let's do that. Let's do the long way first, okay? Because there's a purpose for that. You multiply the 12% to 5,400, but you just cannot use 12% straight. But first, you have to change that into decimal form. So let's do 12 divided by 100, and you get 0.12. And then you're going to multiply that, 0.12. Again, if you want to find the percentage of something, you multiply it, okay, by first changing the percent into decimal form. So if you do, everybody, let's see, where's my calculator? Let's do 5,400. Would everybody do that? 5,400 times 0.12. And what do you get? You get 648. Very good. Thank you, guys. Now, what does that represent? $648. Is the car going to be worth only 600 bucks? No, that's the 12% that you're going to lose, right? That's the value that you're going to lose. You're going to basically lose 648 bucks out of 5,400 bucks. So what is the car worth? We are interested in the worth of the car, isn't it? In other words, we need to think, yeah, Francisco said, right there in the chat, he said, we need to subtract the value that you're going to lose, okay? So let's subtract, so 5,400 minus 648 bucks. And that will be 648. So the car is going to be worth 4,752. Does that make sense? Now, the question is that I have for you guys is, how do we go from 5,400 to 4,752 directly? In other words, what can we multiply to 5,400 to get to 4,752? And we already have the answers in the chat. Thank you, Gentry. That will be, you are going to multiply 0, he says 0.88. Now, if you have forgotten about exponential decay, where did 0.88 come from? Or what does 8.88 represent in percentage? That's 88%, isn't it? Right? And where did that 88% come from? Well, yeah, very good. It's in the chat as well. Thank you, guys. 88% come from 100% minus 12%, isn't it? And that's exactly what you're going to do, okay? So we already know that initial value, that's a 5,400. But what is the rate? The first step is you're going to subtract the rate of decrease from 100%. Okay, so since it is decreasing 12%, we're just going to subtract 100% minus 12%. That's 88%. And that will be the rate of decrease. And then we are going to, second step is you're going to divide that 88%, divide that by 100 to convert 88% into decimal form, which is 0.88. And that is the number that we are going to use, okay? So the equation is going to be y equals initial value. Again, it's still the same. The format is still the same. A times b to the x power, okay? And the a is the initial value, which is 5,400. And then the rate is 0.88, and then to the x power. And that will be the equation. And now, let's say after driving for 6 years, let's say you decided to sell. So how much is the car worth? Let's figure out. Y equals 5,400 times 0.88 to the 6 power. Let's figure out. Can all of you take out your calculator? And let's figure out the worth of the car after 6 years. How much would that be? Is everybody okay on that? So your calculator, let's see, hang on, let's write down the answer. 2,507, or maybe let's just round off to the dollar. So 2,500 bucks, about half now. Okay. And that's pretty typical. Lose 12%. Maybe if it's a good car, only loses about maybe 10% or even 8%, 9%. And that's pretty typical. Yeah, what do you guys think? Is this, again, just going back to about 88%, right? If you lose 12%, but if you're interested in how much is that thing, car or computer, be worth, you want to know how much of the value you're still retaining, right? So you want to figure out the rate of retention rather than the rate of the decrease, okay? Decrease is the part that you're going to lose. But if you're interested in the value of that car, you want to figure out the other part where you are retaining, right? So if you lose 12%, you keep 88%, right? So you need to use 0.88. I hope this makes sense to you. So again, the 100% come from, 100% is the whole thing, right? It's the 5,400. That's the 100%, right? But if you lose 12%, you're going to subtract 100% from 12%. And that's where the 100% come from. I hope that makes sense to you. And then, again, at the beginning, year zero, when you purchased it, it's $5,400. That's what the worth is, of the car is, right? So you paid for it. It's worth $5,400 right now. But that's 100%. And then you lose 12%. So you subtract 12% from 100%. Keep your question coming, okay? Just send it to me directly and I will try to do my best to answer that question. Any other questions, guys? You okay with this? Does anybody need more time to copy this down? Now let's just jump right into the assignment. I think you guys don't need to really do any more of examples. So let's just jump right into the assignment part. Okay. So I've got 6 problems they are all exponential decay problem, okay, of different various stories, scenarios, settings, and so, but essentially it is all the same. The procedure is all the same, okay? Again, exponential function is that, okay? A is the initial value, and B is the rate. In this case, a rate of a decrease, okay, or rate of retention. That's right. You always subtract. So let's do the number 1, okay? So you take the ibuprofen, let's say 400 milligram, okay? And those are all good example of exponential function and specifically exponential decay problems, okay? So you take ibuprofen, 400 milligram, but ibuprofen in the person's system in your body decreases about 29% every hour, each hour, okay? So each hour, 29% of the ibuprofen is consumed, digested, and then goes away, right? So the question is, how much ibuprofen are still in your system, in your body after 6 hours, okay? So let's go through this step by step, okay? The first step, well, we already know what initial value is. A is going to be 400, right? That's A, but we need to work on the rate, okay? So then that's 29%, but we cannot just use 29%. So what do we do first? The first step is you're going to subtract 29% from 100%. So 109 minus 29, and that is, what is that? 71%. In other words, 71 every hour, 71% of ibuprofen is still inside of you. Does that make sense? Because you lose 29% of ibuprofen. That means you still have a 71% in you. And that's what you are interested in, isn't it? How much ibuprofen is still left inside of you. And so we want to use 71%. Now, but we cannot just use 71% straight, but we have to change that 71 into decimal form. So you need to divide that by 100. So that will be 0.71. So 0.71 is the rate of decrease. Okay. Make sure if nobody's waiting to get inside the class. Okay, very good. So now let's form the equation. Okay, so it will be y equals initial value 400 grams times milligram times 0.71 to the time is 6. Exponent is the time, right? So it will be 6 power. So let's take out your calculator. Now, for those who are not familiar with the exponent button, you type in 400 times, right? 0.71. Now you need to do the exponent, right? My calculator has exponent button like this. Or maybe some of your calculator might have y to the x. That will be also the same thing. That will be the exponent button, okay? And then you type in 6, and then enter or equal button. Now let's figure out how much ibuprofen do you to the 6 power. What do you get? Is everybody comfortable punching that in the calculator? What do you get? And let's write down the unit too. 50. I got 51. Now 51 what? Is it $51? 51 rabbits? 51 what? 51 milligram of ibuprofen. Okay. Did everybody get that? Okay, now let's do number 2. In your notes, maybe you can just write down the minimal information here. Don't write the words word by word, verbatim. Just write down computer 2100. That's a very expensive computer, by the way. And then for current now standard, and then the rate of decrease is 35%. And then we want to figure out the value of the computer 5 years from now. By the way, about 25 years ago, 20 years ago, when, no, just write down the minimal information like a, yeah, let's write, yeah, well, okay, you can just write down the equation. 20 years ago, 22 years ago, I was dating my wife and she bought a computer. And again, it's about 20 years ago. And that computer, I think she paid over $2,000. It was the top of the line computer. But it had 2 gigabytes of the, what do you call it, hard drive. And that was like, wow, 2 gigabytes. That's a lot. Who would need 2 gigabytes? You know, there was no computer program that needed more than, you know, that much of a the hard drive. Now you got what, 500 gigabytes, what, terabytes. It's just amazing how computer has changed. And now you've got that. Your cell phone is 100 times better than that computer 20 years ago. It's amazing what kind of technology you guys will be using 10 years from now, 20 years from now. Anyway, All right, that was, I digressed. So the first step is we need to treat that 35%. Are you guys all done with this question? Sorry if I interrupted you. You have to, again, first subtract 35 from 100. And that will be what? 65%. You only retain, the rate of retention is only 65%. You only retain 65% of the value next year and the year after that. And so, and then we need to treat 65%, convert that into decimal. So for that, you divide by 100 and you get 0.65. So that's what we're going to use. Y equals 2100 times, let's write that again, 2100 times 0.65 to the 5 years. So the fifth power. How much is a computer worth? I don't know if 65% retention is reasonable. $200 maybe. I don't know. That might be a little bit too low. Well, maybe that's what the reality is. $243. Maybe 35% is a little bit too high. It seems to me, but anyway. If that's the case, in 5 years, the computer is now worth only $240. Yeah. Okay, next question. I'm gonna let you work on it first. So let me give you a minute. And we'll go over. We'll use the timer. So do you know what to do now? What do you do first? Just follow the step. Exactly what we did in number 1 and number 2. Does anybody have any birthday? Let's check your birthday. Nobody's having birthday? No. Okay. Okay, it's been a minute. Let's check. So the rate is 2.3%, decreasing. So the population is decreasing. It's a made-up story. Leave town. The population of Leave town. Yeah. So first you have to, again, you don't really need to write this part once you get comfortable working on this type of problem, but I'm gonna write it. So you have to first subtract 2.3% from 100, and that will be, what is it? 100 minus 2.3, 97.7%. It's still percent. But now we are going to convert that percent into decimal form. Divide by 100. That will give you 0.977. Do not round off percentage, okay? Otherwise, your answer is not going to be correct. So now let's figure out the population of the town. 123,000 people. 0.977 to the 10th power. What did you guys get? The town is 97,465. Let's write down the unit. People, right? Let's make a habit of writing the unit if you know the unit. We're talking about number of people. Okay. It's kind of a little depressing. The town is dying, isn't it? There are lots of towns like that in Japan. Did I tell you that I'm from Japan? Yeah, I told you guys, right? The population of Japan is decreasing, and it has become a big social problem because now less and less young people are supporting the older generations in terms of social program, social security, Medicare, and all that, right? And so the population pyramid is like upside down. You've got big population of older generations, and then the younger generations are becoming less and less. And so it's actually a very, very serious problem. The average of the children that each the household in Japan is having is less than 2, like a 1.5 or 1.7 statistically. Right. Yeah. Anyway. All right, let's move on. Radioactive element decays at the rate of 5%. Okay. So let's say you've got 40 grams of that radioactive element. How much substance remain after 25 years? Okay. I don't know if this is like we don't even know what kind of element it is, but let's figure out. Okay, 1 minute. Number 6 is the last question. Okay. Would you share your answer in the chat for number 4? What do you get? 11 grams. That's not too bad. Some of the radioactive materials, they don't go away very easily, is it? But this one is 5%. So 100 minus 5% is 95%. So 95% is going to be present next year, 95% year after that. So it would be 95 divided by 100, that's 0.95. Okay, y equals 40 gram, that's the initial value, and the rate of a retention is 95%, 0.95 to the 25 years. And even after 25 years later, only 40 grams to begin with, 25, you still have 11 grams of material still left after 25 years. Okay, number 5. Again, it's the car example. This time it's 8,500. Rate of decrease, depreciation rate is 8%. What is the car be worth after 5 years? Is everybody feeling comfortable working on this type of problem now? So let's get started. Again, you subtract 8% from 100. That's 92%. You can kind of do that in your head too, right? So you don't need to write it down everything, but that's what you need to be doing, okay, on the paper or in your mind. And then now we need to convert 92% into decimal form. And how do you do that? Divide by 100. So it's a 0.92. So now we can just figure out y equals initial value is 8,500. The rate is now 0.92. And then to the 5 years. How much is the car worth? $5,602. Have you guys used Kelly Blue Book? Do you know what that is? Nowadays, you can see the Kelly's Blue Book online, but actually it used to be an actual blue cover book, and it's called Kelly's Blue Book. And it's just a chart of rows and rows of numbers, and you can find the value of the car for any model, make of the car. And let's say if you want to sell your car, you look into the Kelly Blue Book. Let's say you have a car, 2015 Toyota Corolla or something, and if you want to sell it, you can look into the Kelly Blue Book, and you look into 2015 Toyota Corolla, and then it gives you the value. And how are they creating that chart? The rows and rows of numbers. Well, they are actually using this similar, the exponential decay, the pattern, and they have that formula for each percentage for different cars. If the car is good, mechanically good, they have probably smaller rate of decrease, right? And so they have the equation for each type of a carb. Anyway, all right. Last problem. Population of a certain species decreases at the rate of 3.5%. Not good for that species. And you count 80 species in the habitat. How many animals will be left after 8 years? Okay. Let's go through that. You guys know what to do? Again, 100 minus 3.5. That would be 96.5%. You okay with that? And now you change that 96.5. あと5分くらいで終わるよ。Divide by 100. You get 0.965. Okay. So now you've got y equals, what's the initial value? Initial value is 80. 80 species to begin with. 80 times 0.965 to the 8th power, 8 years. What do we get? So 10分ぐらい、5分ぐらいで終わりよ。手伝えるけど。To the 8th power, you get 60. What do you call it? What's the unit species? Animal, 60 animals. Did you get 56? Did I do wrong? What did I do wrong? $80 times 0.965. Did I mess up? Oh, it's a 60. What did I do? What did I guess? Oh, 60. Yeah. Okay. Oh, yeah, 60, right? Very good. What did I say? 65? Oh, 56. I think I may have been looking at over there. Okay, 60 species, 60 animals. All right, very good. Yeah. So I hope you got this. Looks like you guys were familiar with the topic. Maybe it's kind of a review topic for you, but lots of algebra 2 is a review of algebra 1 anyway. But I hope you've learned something. And so this is it. Now let's talk about tomorrow. Tomorrow will be the last day before the spring break. We will meet and we'll do some review up to this point, and we'll do some little short quiz. Okay, and then that will be it. So thank you guys for your participation. And okay, very good. And you guys have a great day, and I will see you guys tomorrow. Take care, guys. All right. See you later, guys. Does anybody need help? If you do, please remain in the class. All right, let's turn off the